Cholesterol is the most common steroid in living things, and from cholesterol, a variety of other steroids can be made, like estrogen, testosterone, cortisone, and vitamin D. Vitamin D has a structure very similar to that of cholesterol because it is produced from cholesterol. Vitamin D is called a vitamin because it is an organic molecule that includes carbon, otherwise, it would be called a mineral. And it cannot be made by the body but is required and so therefore must be included in the diet. This is the definition of vitamin. It is possible to get sufficient amounts of vitamin D from your diet if you eat a large quantity of fish, if you eat mushrooms, which were produced in sunlight, especially if they are dried, or if your diet includes something which is fortified with vitamin D, so vitamin D has been added to it, such as milk. While there is vitamin D in breast milk does not contain enough to meet an infant's needs, and the American Academy of Pediatrics recommends that children receive vitamin D supplements beginning shortly after birth. Many people receive the majority of their vitamin D from exposure of their skin to sunlight. When sunlight reaches the skin, specifically ultraviolet light, it causes the conversion of cholesterol into vitamin D. So those with light skin, especially if they are not using sunscreen, uh, will make vitamin D when their skin is exposed to sunlight. Darker skin blocks more of this ultraviolet light, which is certainly beneficial in preventing cancer, but it decreases the amount of vitamin D which is made. And anyone who spends little time in sunlight, perhaps they work indoors or work evenings, or those who tend to cover large portions of their skin are at the risk of not making enough vitamin D because not enough sunlight reaches their skin. What does vitamin D do that makes it so important? Just as steroids like estrogen and testosterone derived from cholesterol bind to receptors, go into the nucleus, and turn on genes, vitamin D binds a vitamin D receptor, which is a member of the zinc finger transcription factor family. Vitamin D and its receptor then go into the nucleus where they activate genes. By activating genes, I mean that RNA is not being made from a DNA gene until these transcription factors bind to the DNA. Once the transcription factors bind, then RNA copies are made, which then go out to the cytoplasm where proteins can be made. Because so many genes are activated by vitamin D, perhaps 200, there are diverse effects, such as the increased absorption of calcium, the inhibition of cancer, the regulation of immune pathways limiting inflammation, the production of insulin, and many other effects.